Yeah, I took it off. It's fine. Okay. Oh, how can we turn down the light here? Getting better here?
You get rid of this one, that would be.
Yeah.
Okay, you don't have to see me, you can hear me, that's fine. I'm the voice over here. So let's wait another 5 minutes again. Oh, but the ones, if you want to download it, as that's some people came in here, if you want to download the code, you just go to the GitHub page here, download it, unzip it, and then you can open up in that folder the tutorials. And today's tutorial is about React and ClojureScript. So, and there's an index file. You just open that, and it should give you a page with some code to play with. Before we start, who of you are actually working with React in some form or shape already? So have some experience with that? Clojure, anyone? Ha, okay. One Clojure. Okay. So you don't have to know Clojure if you're looking at that. But it gives you an idea of how Clojure works with React in the background. So okay. Let's wait another minute and then we'll start. Yeah?
Can you do a quick plug?
You can do a quick plug, yeah.
I'm doing it's not on the schedule, but I'm doing a, I just volunteered to do it on Friday, 3/29, 11 o'clock. Talk on intro to the Elixir and Phoenix. You're just using the paper schedule, it's not on that.
It's got updated on the app.
Yeah. 3/29? Yeah.
Then I'm doing a plug as well. I'm giving another talk today at 1 p.m. So I handed in 2 talks, thought they would be selecting one, but obviously that went really wrong. So I worked through the night to get everything ready. Okay, let's get started. Welcome. My name is Jochen. I'm originally from Germany, moved here 2010. I work for a small consulting company in Hatfield. We do data processing, front ends, dashboards, and so on for various clients, various industries. And so we do things for the pharmaceutical industry. We do things for ESPN. We do things for marketing companies, click streams, and so on. I personally worked with Clojure for the last 5 years, not exclusively, but more and more so. And one of my favorite things is front-end development, and that's what the talk is about. And since I discovered React as a way to create complex dashboards, complex UIs, I'm really into it, and this is really great, working great for me and for us. It's really fun to develop. And I developed with a lot of different frameworks before I came to React, and also different programming languages before I came to Clojure. So this is currently my favorite combination. And so I know a little bit of Angular, I know GWT, and those big frameworks that come with a lot of bells and whistles. React, if most of you, I think, don't know React that well, is actually a very out-of-the-way framework for creating those components and stateful components that you can then basically mix on a dashboard, and the state is updated automatically. So it's rendered. Let's take a look at the code. As I said, if you want to follow the first step, the first few minutes of the talk, download the code, and if you go to the folder here and open the index file in the tutorials React Frontend, then you will see hopefully the following code here. So we're gonna first take a look at React, what it does and what it is, and a fast forward. We're gonna look at Reagent, which is the Clojure wrapper around React. It's not only a wrapper; it's basically making React really easy to use and understand. Then I have 2 examples for you, and we're gonna go over and look at the more complex example and how that development with React and Reagent works with an editor, not only here on the website, but also with an editor, because most of the complexity that I had to deal with developing dashboards and so on was actually in the development process. You have to reload, you have to do all these kinds of automatic things that the development cycle is actually fast enough to see progress. So let's dive into React. So a few years ago, it was very common that you manipulate the DOM model in the browser directly. So you update the DOM, and every time something changes, you had to manually basically invoke the change on the DOM tree. React abstracts from that. It provides a virtual DOM. It batches updates, and it basically is very tied into the browser to optimize the rendering cycle. So when the browser re-renders, it has a few updates already batched, and it does those updates in one go. So it keeps basically a virtual DOM as a kind of a copy in the background as a model, and then manipulates the DOM in one shot, a lot of those actions. That makes it very fast, and also has some other advantages. So, and when you render something in the browser, you tell React to you give React a component to render, and where it should be rendered, in which DOM element it should be rendered in the browser. So as you can see here, there's a Eclipse container. This is the React DOM render command. You can hand in. It looks like HTML, but in fact it's JSX. So it's a kind of HTML. It looks really like HTML, so you feel really at home with it quickly. And the Eclipse container is just what's in the website at the bottom here. That's the container. This is just a div element that's automatically rendered under this below this code box here. If you have downloaded it, you can actually change things here, and it will dynamically update. So you can play around with that a little bit. It will tell you if you do something wrong. So if you have a div, you see this is. So feel free to play around with that. It will update. So this element, as I said, is actually JSX. Is the syntax extension to JavaScript, and it's translated dynamically in the background in a function call to create this element. And the first argument to create element, if you is the element name itself. It's p. Then we got all the attributes, value combinations as a map, and then the children. So, and you can also manipulate that. So you see actually how that influences the create element command. So this is what it's translated to. So if you execute that further down, what React does, and you can see now, I'm gonna turn it off here. Okay, you can see now what React in the background does. It creates this at the bottom, creates this regular object. It's nothing particularly special. It's an object which tracks a lot of the data, the references, and so on. The children, the class name, those are all the props of the object, the properties of the object, references. This is not here the type. So that is actually what's in JavaScript in the background. The whole DOM tree, virtual DOM tree, is comprised of those JavaScript objects nested. So now Reagent, now we're coming to Clojure code. Reagent is a library in Clojure that makes those component creation extremely easy. So if you have a ClojureScript in your editor, it will be translated into JavaScript. It will be compiled into JavaScript. But Clojure offers a very simple way of creating those components. And this is a div component. It will be rendered as a div element in the DOM tree. And you can manipulate that. So you can change that. You can also dynamically update that. And this is a vector in Clojure, so with the square brackets. And the first element it has this kind of colon. It's in Clojure, it's a keyword. And it basically is just a special data thing. Like I could also use a string. But this keyword indicates that it should be translated into the element, the HTML element. And then you have your children. So this is a very simple way of creating a DOM element. So, and feel free to interrupt me at any time. So if you have a question, I'm open for any question, can go left and right a little bit from that. So let's look at how you create multiple components. And there are multiple ways of doing that. One option in Clojure is for. It's kind of a for loop, if you know that. And it dynamically binds all those names to the var name here. It's kind of a variable. You can think of it that way. And here we create basically in a for loop list element. And you see, this is a sequence of list elements created by this. And now we can take those list elements and embed that again as children in UL element. So you have a list item element, and then you have your list unordered list element. So you just put it in here, the code, and as you see, you can see at the bottom, those are rendered like an HTML list. So, and you can change it if you want to. You can also do that, which is not valid HTML, but works nonetheless. So you have this kind of nesting capability, and that's very handy. We'll see later much deeply nested things. So now you can create your own elements, not only the div element or so. You can come up with all kinds of elements, and an element in Reagent is nothing else than a function that returns another element. So here we define a function called hello message, and the argument to the function is a name. So, and what it returns is just the last thing here, which is the div element hello, and it plugs in the name into that string. Which then, when I invoke that component, give it a name, it says hello Jochen. So this is a way to give it a parameter or an argument. And so we have created our first custom component, and it's actually all boiling down to React. So it's nothing else, just a wrapper around those layers that you saw before. And if we compare that, I'll take that off here. If you compare that, there's React JSX on the left side. Is it big enough?
Yeah.
Okay. There's JSX on the left side, and I try to replicate exactly what the Clojure is on the right side. So if you're familiar with React, you will see that it's not much different. It's not a lot of typing saved. I can save typing with Clojure. It can be very concise in Clojure. But the main difference for me, at least, is that in Clojure, everything is data. So everything is a data structure, and you can manipulate your code as data. And I give you an example here. If you look into that here, you get properties. The hello message get a property, gets plugged in. It's a little bit different than the example before, in that I hand in a map with name and Taylor, with name and value, and I take out the name out of the properties, and I take it out of the maps. This is just a very short way in Clojure to write this, get it out of the map thing. This is the keyword, and I take it out, Taylor, plug it in, and it renders hello Taylor. So the difference is that this structure here is data. This is just a vector of a keyword, a string, a function call, basically, and that's it. And so when you're building your application, you can dynamically generate this code much easier than you can generate this here. This is not a data structure. This is basically more or less handwritten. You need to write it down. So that's a big advantage of Clojure, ClojureScript over JSX. So that's the main difference, basically. Other than that, it's more or less notation. There are other things that we'll point out later. Okay, so now those things are just rendered. There's no change in it. The component doesn't change. It has no state. They're stateless components, basically. And if you see, I type here, I can change my name, and it updates below. But it's not actually dynamic in a way that React does it. But it's the tool that I use to display the site and make it available so you can change things. So don't confuse the editor. When I edit it here, I mean, you edit it here, it's not React actually re-rendering it. There's no dynamic thing happening for React at the moment. And now that's the first thing where we actually change something dynamically in React. Ooh. So here I create and that needs some explanation. I create an input field, and it's a function that takes no argument. So, and there's a next step. There's a let binding. It's basically a local binding, local to the function. There's a binding of a state. So and this is an atom, and an atom in Clojure is something that you can change the state, and you can dereference the state at different places. But you have consistency. So if somebody updates the atom, you hold on to the current state, you dereferenced it, your state doesn't change. So it's thread safe. That makes it on a Java platform. If you're multi-thread environment, Clojure has those constructs to make it thread safe. So so we have a state, and the state is currently just an empty string. Now this is something that is especially, you return another function. So the result of the function called to input field is another function that has the same arguments as the outer function. And that function itself returns the input field. I'll come to that later. So for reagent, that's a signal that you have a local state. So the input field, the outer function, is only called once when the thing is placed into the DOM. And every time the state of that input field changes, only the inner function is called. But it's never calling the outer function again. So that means that the state is local to the input field, but stays stable over time. It's not always reinitialized. Yeah? So, and React has those lifecycle methods that you can call, and that is basically the render method. So you render something, and you basically re-render. The shorter re-render cycles happen only in there, in the inner functions. Okay, let's take a look at the component here. It's an input field, renders the HTML element input, and those are the usual what you have as attributes in your HTML. So it's a type of text. The value, I dereference the state here, and what that gives me back is the current string, the string at the moment when I dereference it. So then on change, I say, okay, I get an event. That's actually the JavaScript event that's a function gets an event. I pick the from the event the target value, which is my new value. Then I just log it to the console, and I reset the state with a new value. And that the resetting the state actually triggers the re-rendering of the element. So at this point, when I reset the state, it's a signal to re-render. It's not immediate because remember that that's just the batching, so it probably batches a few updates if there are other updates on the page, and does it in the next render cycle of the browser. So let's take a look at what that does in the background. Okay. Okay. I need to scroll down, sorry. Okay. Here's my okay. Yes. So here's what it does. I type, and you see in the log, it's logging actually every time on change. It's log and resets the state and re-renders it. So when I don't change the state here, actually re-rendering it, but it's not giving the new value. It's always the old state that it renders. So see, I can type, but it's not taking my value. So it really looks at, you need to really have the local state. That's a difference from an unsupervised or uncontrolled input field. You can type in the input field, but it then doesn't keep track of the state. So here, because it dereferences the state here, you need to set the state to the actual current value. So that's the most complicated thing to understand here, that how that re-rendering works. Is that clear to everybody? Is that we have a couple of other examples on that. So we're taking it a level higher now, even. So right now I don't do anything with the input that I put in. So I can, once I call the input field, I don't actually have the state. It's in the function. So I have no control over the state from the outside, and that's good. So you cannot necessarily manipulate the state from the outside. It's local to the text field. So what usually happens if you look up examples of React or Reagent, the value, the actual current value is handed in from the outside. That's one possibility. So you track the state outside of the input field and hand in the value and just plug it in here. So you don't have that local state. But that's kind of the thing when you want to save a state from the input field. Like you want to save a state once you leave the input field. That's hard because every time you type, then you would persist it to the database, every single keystroke, which doesn't make sense. Or might make sense, but in most cases it's too much. So here's what I usually do. I hand into the input field as argument a function that does actually the persisting. And the persist function expects the current value. So, and when do I persist? It's called on blur. So either I leave the field or I do something like on key down when I hit enter, I stop propagation and blur, which then triggers the saving of the input field. So, and how that's done here, that's everything else is the same, right? The input field, I have this function that gets a value and just alerts it to the JavaScript alert. So that function is handed in and is called as soon as I blur the input field. Let's try that on. Nothing happens right now. So now I click some, and it calls the persist function. Now it goes to the database, not on every keystroke. So that's a usual pattern. And that's important to understand that you React, usually what you do is you hand in properties, those are values, and potentially state. And but a better pattern is actually to have functions handed in as an argument and value. So there's all kinds of combinations possible. Reagent gives you much more freedom than React in doing those things, like coming up with a good way of handing in arguments. And it can also mess up more. So it's kind of, yeah, you can shoot yourself in the foot. But, okay. Okay, enter. Does that work? Yeah, it works as well. Okay, so there's an example out there. It's a longer example now of a full application, and I scroll all the way to the bottom to see what it actually does. It's a body mass index calculator that I really need, and so I changed my. So I'm actually. And I cheat a little bit because the next thing is obese, so I don't want to have that. So I'm just overweight. So it calculates. It basically what it does is it's those sliders are connected, and so you have to do the calculation. That's the business logic side. You have to calculate the body mass index or the weight, depending on what you actually move around here, right? So you have to calculate the weight, or if you changed one of those, then you have to calculate the body mass index. Business logic. And then you have to kind of, if you would program that, you have to kind of tell the other sliders to change accordingly. And you have to get the value from those. And now imagine you would do that with regular JavaScript and DOM manipulation. It's painful. And so let's look from the top here. Here are the two business. Oops. This is the business logic here. Those two functions, let's scroll them up. Calc BMI, calc weight, nothing in particular interesting here when you know how that's calculated. Anybody doesn't know what body mass index is? Okay. Anybody doesn't know and don't want to say it? Okay. I'm not going to go into that, but okay. So here, I need 3 sliders. So the basic thing to do is to come up with a component for that. And there are multiple ways to do that. Online, there's an example for that. It does it a little bit different, but very complicated to reason about what's happening. So I changed that a little bit. And what it gets is properties. And this is for Clojure a very short way to say, pick all those things out of the map that you get and bind them to the actual variables or bars. There's no variable, but I call them variable for now. So we get a minimum value, a maximum value, the actual current value, and what to do on changing the value when a value changes. So, and what it returns, and this is an example where I hand in the value from the outside, right? Not only the function, but value. So there's no local state to it. And here's the input field. It's a range, width, and set min max. Those are the usual attributes in HTML. So nothing value as well. So I set the value. And on change, it's basically the boilerplate code to pick out the current value from the event. So I get target value. And then I call the onChange method that function that I handed in with this new value. Okay, and one lower here is actually the BMI component, which is a little bit more complicated. That keeps track of the local state. And the local state is the 3 values, basically. That's it, right? So, and the inner function, which is called every render cycle when something updated. And here, I dereference the state that's a short way to say deref, this at sign. Dereference the state. I pick weight, height, and BMI. This is basically those 3 values. I pick those out, bind them to weight, height, and BMI. Let's jump over that for a second. It's not particularly interesting at the moment. And then I have those bound. I say, okay, give me the integer value of the height, and here's the slider. Here I call the slider component. So I have a slider component, minimum, maximum. The value is currently the height, so I track the height with the first slider. And on change, I get the new value, and I reset the state with the new value. I change the height, right? So I need to set the value. The width, the weight is the same, so it stays the same from the state, and it calculates the BMI given the new value and the weight. That's it. It's pretty simple, and that's going to be done for all 3 sliders in slightly different ways. So here you can look at it. I don't go into detail, but those are basically just slightly different ways of calculating things. And every time you slide something, then I get an on-change. If I do the weight, then I reset the state, which triggers the re-rendering with a new state, right? So the state is changed. I re-render. I dereference the state, render the whole thing, and then I go again. And while you're sliding, it's re-rendering all the time, but it's incredibly fast. So you don't even notice that there's some re-rendering going on, right? So it's incredibly fast, and that works in the browser. Like it's and reagent is actually faster than React in default because Clojure provides immutable data structures, and that means that React sometimes doesn't know when a data structure changed, and Clojure makes sure that only if you change an atom, then something can change. So if no atom changes, nothing changed. So this is kind of where reagent and Clojure is actually faster than native than React taken out of the box, right? Questions? Yeah.
So what you're saying is reagents not really compiling. I mean, I don't quite understand how the transformation works between reagent and React. Okay,
good question. And we will see that in the editor later. But so ClojureScript is a subset of Clojure, which is actually can compile down. So if you have this kind of code, can compile down to the JVM bytecode. So you run it on the server, or can compile down to JavaScript. So while you're developing, actually, with this kind of notation here, it's going to be translated, or if you deliver your code, it's going to be translated into JavaScript, and that in itself has then at the lowest level the actual calls to React create element and so on, right? Or React DOM create element and so on.
So in the DOM, it's not actually using Clojure; it's just using JavaScript.
No, the browser doesn't know anything about Clojure, ClojureScript whatsoever. Everything that you see here is basically compiled. This code is on the fly compiled in the browser to JavaScript using a compiler that is written in ClojureScript, which is it's crazy. But there's a lot of technology going on in the background here. But you usually don't have to care about that. Nobody cares about Java bytecode or so. Yeah, right. So it's just a compiler step, and it's actually very easy. You don't have to do a lot. And I will show you the development cycle in the editor, which is important to understand that it's not only here in the browser. You can actually develop in your IDE and see changes live on your website. Other questions? Okay. So let's take a look at the charts example. Let's go to the editor, actually. So there's another example down here, but I have also that in the editor. And there are links on the bottom if you want to go and check them out. Okay, so let's go over to the editor, how that looks like. So the source code is basically, that's the app. Let's close that. That's the front-end app. And I have 3 examples. I'll show you the front-end app before I actually show you the code. There are 3 tabs on that. That's the body mass index. That's the actual then application, not only the fancy website tutorial thing, but that's the actual application. There's a to-do app, so you can have 3 examples here. That's a to-do MVC, if you know that, to compare JavaScript frameworks. That's this kind of thing. There's charts, and there's the body mass calculator. So how does that work here? This is already driven by React or reagent. And if you look at that, I load reagent like before. I define the tabs that I have. And take that out, move that over a little bit, that down, that over. Okay, that's better. Is it still big enough, or is it? Presentation mode kills the whole thing. That sounds reasonable. Let's see. Maybe I need to point it out that way. Nah. Yeah, let's zoom in a little bit to the parts. So they're just definitions that I came up with that. That's nothing React or something. It's just a map that holds the label and the actual components that are loaded from some other namespace. So and I have a current tab ID, which is the atom. So if that changes and it defaults to the first tab, so when you start it, it's the BMI, body mass index calculator. And let's take a look here. So the nav bar, that's the tab bar on the top, is actually just an element here, and I create the tabs bit by bit, like I showed you before with the list items. And this is the actual list item. It just checks whether the current tab ID is the tab ID that we have here, and then it's active, which makes it blue, right? And on click on some of the tabs, I reset the current tab to the tab ID that I have currently, right? That I'm clicking on. So that's basically it. That's all that drives the tabs. That's the code. And that's the content here. So I get in tabs the current tab ID and the content, which is then the component that's rendered, right? The BMI component. And we're going to take a look at how that looks like. I would go over to the chart component, actually. So, and now the development cycle, if you usually develop, you have to reload all the things. And here, if I want to change something in the code, like I want to give it a different title, I save it. And might take a while for the first time. Yeah, the first time it has to compile a lot more. So on the left side, see on the right side, in my IDE, in Clojure code, basically, I change something, I save the file, and it automatically recompiles to JavaScript, pushes it over to the browser, puts it in the right place, and changes just that, right? So I can dynamically change the things here. So if I save, it's going to go back to normal. Or if I want to just change the order of the tabs, I just flip it over here. See on the left side, you just flip things around, and you're very, very short cycles in the development. So you can actually do those things. And if you make an error, you can say, okay, the default should be different, or if I take that out, active, I have the CSS class is not right, so it's missing, so I have to fix that. I fix that. Is that right? Yep, it's right now. So you can see it's going back and forth, and it's very quick in recompiling and pushing it. And that's not only for the JavaScript code. You can also say, let's see, we have something margin. For example, I change the CSS file, I save it, and you get the updates immediately on the left side. So whatever you work on currently, it's a really fast turnaround. So, but that has nothing to do with React. That's just ClojureScript and how it basically interacts with the browser. And because ClojureScript can actually has a REPL that connects to the browser, I can do things. Let's do it on the right side here, like JavaScript alert hi, and it pops up. So I'm writing ClojureScript code, whatever I need to do, on the right side and send it to the browser, and it immediately executes on that side. So let's try things out now. More reagent React way. If we go to the charts app that I have, and I'm going to show that a little bit bigger now, because that's important to see how that works. That's bigger.
That's bigger.
But then I can't put things on the side and left and right, so it's kind of painful to see the live update. So I need to make it a little bit smaller. But I'm going to walk you through, and we need to watch our time here. So what it does is it has that's an example of how we can interact with bigger JavaScript libraries. And one library that I use is eCharts, and there's a specification that you have to hand in to create some bar chart, and that's just basically data. That's configuration of that JavaScript library. But what's important here is that there's a chart element, a React chart element, and React provides you with lifecycle methods, and those are important if you interact with some bigger library and have to set up things that are not necessarily reactive, right? So here you have a render function, which just gives you back the canvas, basically. Once the component actually, and you're not creating it here, you can't do anything. Once the component actually mounted in the DOM node, in the DOM at the right place in the browser, this here is invoked. This function is invoked, and what it does is it initializes the JavaScript library eCharts with the current DOM node where it's located. It sets option, and that's just the JavaScript library commands that you have to use. And once the component updated, I need to tell the underlying JavaScript library, which is not reactified, right, that we have to set new options with a changed specification. So now I need to go back and exit the presentation mode, and let's take a look at how that plays out here. Let's go to the charts library. So this is the bar chart, and this is just driven by that code. That's all it is. So you have your numbers here, and you can actually now change the specification, because the specification is an atom here on the top. It's kind of too small, but you change the specification, and then this triggers a re-rendering of the whole chart. So let's go through that. I can give it a new title. So what that does here is in the specification I change the title text to new title. Right? So let's need to load the namespace and new title. So that's React now. So that's currently changing. That's handled by React. Or I can change the bar charts by handing in new data here on the right side down here. I could change. I can add a new type of data, which is this bar, or a new thing. I can completely change the specification to something else on the fly. So I can really play with what I can set the original data here. So it changes. I can change as I develop the application and set those properties right, sizes and all of that, until I'm done, and then I put it in code. I can set arbitrary things, and now we're at the very end, and I did something. There's a weather station down the road here. And if you've seen that, it's just down there, it has this wind indicator here. And so to automatically update, not that I do manual updates, but I can start basically an endpoint to grab this data from the same location they grab it. They didn't need a password or a key for that, so that's fine. So what I do is I start an endpoint, and while the endpoint is running, it's everything that is updated is putting into a channel. So I take it out of a channel, the current conditions, I log them, and I set the wind speed from the conditions to the specification, to the data of the specification. So that's actually really dynamically updating it, right? So let's see if that works. Okay. Okay. Let's see. Might lag behind a little bit, or a little bit ahead. So that's good. I'm faster than they are with updating the stuff here. Yeah. Okay. So that's basically the React component automatically updated with incoming data from a channel. So and the channel itself does all the transformation from the response that I get automatically. So as soon as I plug it out of the channel and put it into the component, it's already formatted in the right way. And if you want to see the code for that, that's the whole code to plug out the station data and process the data. So yeah, that's all I have. And there's more. So if you check out I'm just running out of time, so I don't want to go over. If you check out the code, you will see another example, the to-do application. You can play around with that a little bit. You can compile it, and that's all in this website. You can play around with the BMI calculator on the website directly. You don't have to have an editor or something. But you've seen that there's a cycle, that the complexity is really, really manageable even for larger sites. And I developed larger one-page applications with that. And it's not only the components are easy to develop, it's also how to develop those components is very easy. It's very interactive. It's actually fun. And that's sometimes missing in programming these days. Yeah. Okay, any questions?
Yeah, so could you just take a second and talk about the to-do app? It's not the tutorial app in which you were evaluating, maybe I missed it. It was something like a Jupyter notebook, but it was for just actually evaluating your ClojureScript within some markdown text talking about the presentation. Oh. What is that something you wrote specific for the presentation? Or is that
yeah. So you mean that code? That kind of. So what's going on here? Whoa. Okay. Next talk. But what's going on here is basically it's ASCII Doctor, and you might have seen that. But ASCII Doctor is just a. I can show you the original code that drives that. Let me go to the tutorials here. React Frontend, and the BMI is just that, because I actually take out the code from the actual code in the file. So I don't type that here again in ASCII doc. It's like Markdown, right? But I take out the code, React Frontend, BMI, CLS, and if I change anything in my BMI code here, actually, then to the power of 3, that's if I change that and I reload that in here, it's just gonna blow it up, I guess. So the let's see, where is the BMI here? To the power of 3. Here you go. So what's going on in the background is there's a thing called Clipse that provides this compilation of ClojureScript code and other code. You see there's JavaScript, there's ClojureScript, there's all kinds of languages. It does it on the fly and provides the result of that evaluation on the bottom. And that's what I use here. It's ASCII Doctor as the general framework to create the document. and Clipse. Clipse. I think I have it on the, at least in the README on the in the Clojure meetup. Here on the bottom is no, thanks. You will find it. Here slides. Ask a doctor. Real. There are also slides. Here, Clipse. And I modified it a little bit, so it's kind of hacking it away, sending patches to the framework. So that's a good way to present. But is that other questions? Yeah.
So why do you dereference the state inside the function, like whenever?
So dereferencing the state is the signal, basically. It's basically the only way to change some variable in Clojure. There's no variable. Usually you have mutable variables, and so all the variables are actually vars. They're immutable in Clojure, except those constructs like Atom. There are other ones, but Atom is the most prominent one. And dereferencing it signals React on the very bottom. You need to re-render because your state changed. So every time you dereference a reagent atom, I must say it's a specific atom, a reagent atom, it's triggering that re-rendering state. That's why. And so you can control a little bit when it re-renders. Yeah.
So a lot of people use React with Redux. I don't know if you want to get into this. When you have Clojure, do you not care about it? Would it be busy? You don't need it anymore?
No, you don't need it. It's obsolete. Many of the things. I mean, I just use plain React, and there are, of course, React projects around React that provides with a lot of bells and whistles and a similar functionality of updating and that. So I just go with normal React. And the interesting thing, there are other possibilities around it. And you need to leave. Go to his talk. It's awesome. 11 Elixir.
So where is that one?
320.
Do another plug here. And,
Yeah.
All right.
and afterwards, come to the data processing talk at 1 p.m. somewhere. So, any other questions? Thank you very much.
Thank you.